Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Lupin's Loop 3, Successorless by Rad Baron. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Well, I got a hair in my mouth. Lovely. I think it might still be in my mouth, but okay. We have digits separated by a white crop key dot are consecutive. So, for example, if this were, say, a 6, this digit would have to be a 5 or a 7, because those are the only digits consecutive with 6, and they must be consecutive because there's a white crop key dot in between them. We need to draw a single electricity cable that travels orthogonally from cell to cell, never branching, crossing, or overlapping, and eventually closes into a loop, hence Lupin's Loop 3. The loop must pass through every hut. Okay, so what does it mean traveling orthogonally? It just means going horizontally or vertically. You cannot go diagonally here. So the loop could go something like this. Let's just use that. Could do, and can't do that. It could do something like this, or something like this, or something like this. It cannot branch, and it cannot cross or overlap. And eventually, it's going to have to form a closed loop. So it could do something like this. And it has to go through every hut. So this is an example of a valid loop. You could not do something like this, though. That would be considered overlapping or branching or something like that. The loop, again, must cross through every hut. Water drops mark river borders that the loop cannot cross. I don't think I crossed through any river borders. No, I do not. Any two cells that are adjacent along the loop must contain non-consecutive digits unless the loop is passing through a white dot, where consecutive digits may appear. And any two huts directly connected by the loop form a segment including both huts. And a digit in a hut equals the length of the longest segment containing it. Oh, that's interesting. So, okay. So, no two digits that are on the loop can no two digits that are adjacent on the loop, I should say, can contain, or they cannot contain consecutive digits, or they must contain non-consecutive digits. Another way of putting it. So, for example, if this were a 6, these two digits could not be 5 or 7 because they are not going through a white crop key dot. Now, on the other hand, say we had the loop actually do something like this. Then this is valid to be consecutive because they're going through, the loop is going through a white crop key dot. But also, any two huts directly connected by the loop form a segment. So this is a segment, this is a segment, this is a segment, this is a segment here, etc., etc. And a digit in a hut equals the length of the longest segment containing it. So, this segment would be 1, 2, 3, 4, including both huts. This would be 1. Or actually, I guess 2? Yeah, it would have to be 2, right? Or is it 1? I think that's 2. Yeah, because it's 2 cells, right? So the length of, well, technically the length of the actual segment is only 1. But I think for the it basically counts the number of cells that the segment goes through, I think. And so I think it has to be 2 in this case. So this would be 4 and this would be 2, which means this would have to be 4 because the longest segment for that hut is a 4. This is, we have 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6 here. So this would have to be 6 if that were the case for that hut. Huh. Okay. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's mark all the waters with something that blocks so that we know that we can't go through that way. Do we really need that, though? I feel like probably not, maybe. Okay. Well, we know in a corner, you only have one way in and one way out, so it has to go that way. Then one of these connects to this hut here. So this is going to be 1, 2, or 1, 2. But if it does connect to this one directly, then this hut would be 2 in length also. Also, this can't be 1 or 3 because they can't be consecutive. So these have to be 4 or more for the length in the hut. Which means we cannot go directly here, we cannot go directly here, because then this hut would have a length, segment length of 2 at most. So this has to go that way. That's interesting. This has to go that way, and this must connect that way there. Interesting. Obviously, one of these could connect, but the other one has to go out, which is interesting. Okay. This obviously can't be 2, so this has to be 3 or more for that segment. Okay. Can it actually... Okay, so what digits actually can these connect? We could go 1, 2, 3, 4. We could go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. I don't think we can go 5, though. So we can go 6, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So no 5 is available here. 1, 2, 3, 4, 5, 6, 7, 8. So yeah, what distances? We can't go 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Technically, we could do that. We could do 1, 2, 3, 4, 5. We can't. Yeah, there's nothing that can go 5 here. This could go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Can we do 6? I don't know if we can do 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, 6 is not possible for this one. Oh, well, no, that's not true. We could do 1, 2, 3, 4, 5, 6. That is possible. Okay. Oh, this can't be just 3. If this is worth... Oh, these can't connect to each other. If they connect... Well... No, that's not necessarily true. You could have a longer one going there. That is true. It can't be 3, though. You could have 1, 2, 3 going there, but then this is necessarily longer going 4. So this can't be 3 here. This has to be at least... Actually, I think this is at least 5. The shortest one is 4 away. 1, 2, 3, 4. The longer ones are at least 5 away. 1, 2, 3, 4, 5, 6. So technically this could be 5 away. Going that way or that way. So this has to be 5 through 9. This 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is at least 5 away for this longest one. This 3, but then the next longest one is 4. So this is 4 at least. This cannot be 2. If we connected this way, straight through, then this would have to be 2. And it can't be. So this has to go here. And then it connects to one of these 2. So this is 3. So that's guaranteed to be 3, because it's going to be 2 in one of these directions here. And then it has to go up and then connect to one of these. That's interesting. Remaining digits for these huts cannot be 2 or 3. So it's 4 through 9. This, the closest away is 1, 2, 3, 4. The closest here could be 4. So this could be 4 at... It has to be at least 4. But it can't be... It could just be 4 by itself. This can't be 3 because of 3 in the box now. And the longest one has to be at least 3. So this is 4 through 9 there. Huh. Interesting. This could be 3 away. So we have 3 through 9 there. This could be 2. This has to be at least 3 away. And then it could be another 3 away. But it can't be 3 because of 3 in the box. So this is 4 through 9. Same with this. This is 4 through 9 because one is 2 away, but the other ones are 4 away at minimum. This is 1, 2, 3, 4 away at minimum, so 4 through 9. This can't be 2 because of 2 in the column. 1 is 2 away, but then we have 1, 2, 3, 4, 5 away at minimum. 1, 2, 3, 4, 5, 6, 7 away. 1, 2, 3, 4, 5, 6 away. So this is 5 away at minimum. Going something like that, possibly. 3 can't be here. This is 2 away from here. We have 1, 2, 3, 4, 5 away. 5 away there, 5 away there. So this is 5 through 9. Okay. So those are all the restrictions we have right now. This can't be 3, 2, or 4. So we have 1, 5, 6, 7, 8, 9 as possibilities there. Um, hmm. Um, okay. Hmm, hmm. Huh. This can't be 2. So we know 2 has to be one of these 3 digits there. Um, um, this is interesting because I don't know. I don't have a good intuition on what the longest segments can be. Um, hmm. Uh, um, yeah, I just don't have a very good sense of how these huts have how they have to be long lengthwise. Obviously, you can't have anything greater than 9, but there's no like really restriction there, where basically there's nothing that has to be 9 in length. Hmm. Edges of grid are interesting because we know it has to at least enter from one of the sides of the grid. It could just go that way, though. Hmm. The problem. Okay, so the thing is, one thing that was interesting is that we couldn't have 3B either of these. So because of that, it can't directly just. Well, actually, it couldn't even directly connect. Well, it couldn't directly connect this way because of 2. So that was interesting. Um. Hmm. Hmm. Uh, hmm. Yeah, I'm not really sure how to approach this. I'm not actually very used to loops, which can touch itself for the most part, orthogonally, because it's really restrictive thinking about it, where you have those loops that can't touch themselves. But these aren't those types. These are very generic loops, right? Um. Hmm. Oh, that's interesting. Whichever one this comes out, it can't directly go to the next one here. So, whichever one goes out, that is interesting. So, if we went out this way, you cannot directly connect to there. You can't go that way because then these two have the same length. It would be 4 and 4, and that would be eliminating those digits. That would be a repeat in the row. So you'd have to have this goes separately. This connects that way, so that's 4. This cannot connect to the hut there because then the longest would be 4 there, so it would have to exit out somewhere. This can't be 4. It would have to do something funky like it can't even do that because then that would connect. Can we ever go that way is the question. So if we do that, again, this can't go up. That's only size 2 as the length, and we can't have a 2 because of 2 in the row. So this has to go this way. This cannot connect. So this must go separately that way. This must go this. This cannot go that way. Because then that's 4. This is 4, and that's 4, and that would be a duplicate. So it has to go that way, which means it has to connect there. That's funky. So this has to connect that way if that's the case. These can't connect. This cannot connect to there because then both of these would be 4. So this has to go that way, that way. This has to go that way. And then they could connect. Actually, we could connect here. So we don't. We actually could connect there. 1, 2, 3, 4, 5, 6, 7, and then they would both be 7. Okay, so that is possible. Okay. What happens if we go this way? Cannot go directly up. Has to go that way at least. Can't go directly to that, so it must go that way. That means this has to connect that way. We have 1, 2, 3. It could be 4 and then 5. Oh, but we have a problem here. This cannot connect directly to this. Okay, so we can't go this way then. So if we go this way, again, you cannot connect directly to here because then this would be the longest segment would be 2. Can't connect that way because then the longest segment would be 3, which is already there. So then it has to go this way, which means this has to go that way. This has to orthogonally connect, go to here, and then this must go up there to connect. But then these two have the longest segment on the same in the same box. So this would be 1, 2, 3, 4, 5, 6, 7, but both of these would be 7 in the same box, which is not allowed. So we know then we cannot go this way. So we have to go this way. Okay, that's interesting. So again, we have this same thing. If this connects directly, these are the same segment for the longest segment of 4, and that's not allowed. So these cannot connect. This can't go up, so this must go this way. And these cannot connect, so this must go up, which means this longest segment is 1, 2, 3, 4. So this is 4. That eliminates 4 in the rest of the box. This can't go to a segment that's smaller than 4, or 4 or smaller, so this must go this way. This has to go up to not branch, and cannot connect to here, because if it does connect to here, then both of... Can't it? Why can't it do... because then this would be 4. And that would be too small. So this has to go that way, which means this has to connect here and here. And it cannot obviously connect to there. It can't connect to here because then this would be the longest segment of 3. So this must go up. This then cannot connect to any of these cells, so this has to connect that way. Same with this. This cannot connect to this cell here, so it must connect that way. If we connected straight up this way, the problem is this would be size 4, and we can't have that. So no 4 here. This would be size 2 already. Only one can't be 3. It has to go that way. That was kind of interesting how that worked. Anyways, this has to go up. This could connect to here, and then this could exit out. We don't know. Or this could connect to there, and that's 2. That is possible also. This can't connect here, but it could connect to this. So this is 1, 2, 3, 4, 5, 6, 7. So this is at least 7 here. Or it could connect 1, 2... It cannot connect to here. That would block this out. It cannot connect to... Actually, okay, yeah. So... This is definitely connecting to this portion, but it could connect this way, or it could connect this way. It can't go here and then connect to itself, because then that would form a closed loop just on its own. So this has to be either 7 or 9, because it's connecting to this segment here. So this is 1, 2, 3, 4, 5, 6, 7, or it could connect 1, 2, 3, 4, 5, 6, 7, 8, 9. And it cannot connect to this, because then this would be blocked. Can't go this way, because then that would be connected, and it's blocked by this water thing. Can't go this way, because then this would be blocked again. So therefore, it's always guaranteed to connect to this, and it has to be 7 or 9, and these are the same digit. So we have, we'll make this yellow. So this is yellow, that's yellow there. This cannot be 4, so this cannot connect to here. It has to continue out. Therefore, this cannot connect to either of these, so this must connect that way. Therefore, since this goes that way, this cannot go up here to connect, so this must connect right there. And these are both 7s. So those are both 7s. That eliminates 7 in the rest of the box. And row there. And column here. Okay. This could connect... Okay. That's interesting. So you could technically connect there. We don't know if this goes up. This could connect. 7 eliminates 7 in the rest of the column. No, 4 in the rest of this column. So this connects that way. This must either connect here or connect here. Oh. We enter this way. We have to exit this way for the loop to work. So this must go that way. This cannot connect to here, so this must connect down. And this has to be on the loop. It cannot go that way because it would have to go directly there, so it must connect that way. Okay. So this is, largest segment is 3. This has to be larger than 3. But if it connects this way, if it connects directly to this, then these are the same digit because the smaller one is 3 in length. So this cannot be 3. This is 2. We have 1, 2, 3, 4, 5 here. So this must be 5 there. That eliminates 5 in the rest of the box. This can't be 4 anymore since we already have a segment that's 5 in length. These could be the same digit here for these two, so that's potentially possible. This has to be longer than 3. This cannot connect directly to here, but this could go that way. I don't know. This could go that way. This could go that way. We don't know that. This is at least 6, because it can't be 5, and it can't be smaller than 5. So we have 3 here, 3 here. Remaining digits of row 9. We have 1, 6, 8, 9. Okay. No 6 or 8 here. That's consecutive with 7, so this is 1 or 9. No 6 here, because that's consecutive with 5. So this has to either connect directly to here or connect to this. So what are the choices there? So this is 3, that's already small. 1, 2, 3, 4 is possible, or 1, 2, 3, 4, 5, 6. So this is 4 or 6 here. Connecting either to there or to there. We're not sure. This could connect directly to here, so that would be 1, 2, 3, 4, 5, 6. Or it could connect directly to there, so that's 6. 1, 2, 3, 4, 5, 6, 7, 8 could go that way. 1, 2, 3, 4, 5, 6, 7, 8, 9 could go that way. There's a lot of possibilities for these loops. It's kind of interesting, actually. Never did anything like that before. Anyways, this can't be 5. That's consecutive with 4 and 6. This is at least 4, so it could connect to that. No, it can't. This cannot connect that way. It has to go that way or that way. I don't know which. 5 eliminates 5 in the rest of the column. Remaining digits of box 7. We have 1, 3, 6, 8, 9, and 5. No 3 here because of 3 in the row. No 6 or 8 here because that's consecutive with 7. So yeah, this could still be 6, 8, or 9 there. You know, 3 is one of those digits there. Um... This digit cannot be a 5 either. But we could have 1, 2, 4, 6, no, 7, 8, or 9. And it's a wide variety. This digit cannot be 3 or 5, can't be 2 or 4, because that's consecutive with 3. So we have 1, 6, 7, 8, and 9 available there. Remaining digits in this box. We have 1, 2, 4, 6, 7, 8, 9. Unfortunately, that's still pretty wide open. um, Not really sure where the restrictions on the loop are, really. I mean, they don't seem to be too many. Uh, uh, um, what happens if this connects to here? That means this has to have a very long loop here. Or it has to have something greater than 6. Which could be 7. So 1, 2, 3, 4, 5, 6, or 8. Um, but then this would have to be even longer because they can't have the same thing in the same box. Huh. Uh, hmm. This can't be 7 here. We have a guaranteed 7 in one of those 3 cells. Uh, hmm. Do you have any other restrictions, really? Not particularly. Mm, yeah, I guess I'm really bad at these. I'm so much more used to loops where you cannot touch yourselves orthogonally or even diagonally. That's even more restrictive. But the loops where you're not, I'm just kind of like, oh, there's so many possibilities. Um, hmm, that's interesting. Huh. This could do. Okay, this cannot go this way. We know that for certain. If it goes this way, it has to go that way, and then this would be 1, 2, 3, 4, 5 as a segment, and 1, 2, 3, 4, 5 as a segment. So this cannot go this way. And since it can't go that way, it must go either here or here, which means this cell can never enter this way because it can't connect to anything on the loop. So this must go that way, guaranteed. This can't connect to here then, because if it connects there, again, it's 5 in length. 1, 2, 3, 4, 5. So this has to go that way. And since this must go that way, it cannot connect each other in the loop, so this has to go that way. Because it can't connect here, because both of these would then be 5, which is not allowed. So this has to go that way. This goes this way. This has to go up. So 1, 2, 3, 4, 5, 6. It can't connect to this. So this can't connect to here because that would be form a closed loop by itself, but not connected with the other parts of the loop. So this has to connect that way. And then this can go up, could go to the right. So this size is 1, 2, 3, 4. This size is 3, so this has to be a 4, which means this can't be 4, this is 6. There's no 4 or 6 left in this box. 4 eliminates 4 in the rest of this row. No more 6 here because of 6 in the row. We have a 1, 8, 9 triplet in row 8, which eliminates 1, 8, 9 in the rest of the row. So no 1, 9 there, it's 5. No 1, 8, 9 there. It's 2 or 4. And this can't be 4 because of 4 in the box, so that leaves that as 2, and that's a 4. So 2 has to be one of these 2 digits. So this must be 6, which means it must connect to here. It cannot connect to this cell here. So this is 4. That eliminates 4 in the rest of the column. This is at least 8. 1, 2, 3, 4, 5. Cannot go 6, 7. So then this must go up. This cannot connect to there directly, but it could connect there. Or it could go through that. This can't connect that way, so this must go up. So this connects this way, which means this can never connect to this. So this must go up that way. It's at least 8 or 9. It cannot connect to that up there, so it must go that way. 1, 2, 3, 4, 5. So therefore, this has to go that way. So this has to connect that way. 1, 2, 3, 4, 5, 6. Cannot connect there because then that would form a closed loop without including the others. This has to go that way. This cannot connect to there. It's too small. 1, 2, 3, 4, 5, 6, 7. So this has to go that way. And then it must connect 1, 2, 3, 4, 5, 6, 7, 8, 9. It has to connect that way because it can't connect to any other cell here. 1, 2, 3, 4, 5, 6, 7, 8, 9 can't reach there. So it has to reach there. Therefore, this must go that way, and these are both 9. So we have a 9 there, a 9 there. This cannot be 8 or 9 because that would be consecutive with a 9 there. So this is 5, 6, or 7. 1, 2, 3, 4, 5, 6, 7 getting there. So this has to go directly straight there. And it goes either here to there, or here to there. So this must get to here. This is 7. 9 eliminates 9 in the rest of the box. So that's 5. So no 5 or 9. I don't know what I just did there. 9 eliminates 9 in the rest of this row. So that's 8. No 8 or 9 there. It's 1 that eliminates 1 in the rest of this box. No more 2 because of 2 in the box. 1 eliminates 1 here. So that's 9. 9 eliminates 9 there. So it's 8, which means this can't be 8. It's 5. Okay. 8 eliminates 8 in the rest of this box here. This digit cannot be 6. That's consecutive with 5. This digit can't be 6 because that's consecutive with 5. We have a 1, 3, 8 triplet now in box 7, which eliminates 1, 3, 8 in the rest of the box. So no 3 or 8 there. It's 6. 8 eliminates 8, 8 in the rest of this row here. That's 1, 3 as a pair. Therefore, there's no more 1, 3, or 6 in the rest of row 7. So no 1 or 6 there. This becomes a 2, 7, 9 triplet. That eliminates 2, 7, 9 in the rest of the box. 8 is consecutive with both 7 and 9, so this cannot be 7 or 9, so that's 2, which eliminates 2 there. 1, 3 as a pair eliminates 1, 3 in the rest of the box, so no 1 there, it's 8. 9 eliminates 9 there, so it's 1. No 1 or 9 there, so it's 6. 6 eliminates 6 in the rest of this box. This is 8 in length. 1, 2, 3, 4, 5, 6... 7, 8, and 9 would be that way. 1, 2, 3, 4, 5, 6, 7 would be that way. So this has to go 1, 2, 3, 4, 5, 6, 7, 8 there. So that must connect there. And it cannot be 9 here, so this must be an 8 in length. That means it can't be 7, 8, or 9. It's 6, and it cannot connect. Well, it could connect directly to that. This can't be 8. But it can't be 7 either. And this has to be 7 connecting to this. So this has to be 9 that way, which means this can't be no 6, 8, or 9 here. It's 4 or 5. This connects to one of these two, but it could go out that way, so we don't know. So this has to be length 9, and it cannot connect to either of these because these can't be length 9, and this can't be 9 because of 9 in the column. So this is probably just connecting straight to here. And these are both 5. This has to connect to another digit that's 9, and these can't be 9. Another hut that's 9, I should say. So this must be 9 over here, and it connects to that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, this could be any directions. This is 6. It could just connect directly. In fact, it probably has to. This has to go up because there's no other path, so this must go up because it can't connect to itself. This could connect to the 6 here. 1, 2, 3, 4, 5. So whichever... Okay, so... This is never going to connect evenly to this. 1, 2, 3, 4, 5, 6, 7, or 5. So it must be less than the 6, because otherwise then it would be 7 or greater. So it must connect directly to this. This cannot connect directly to here, so this has to go up. Which means, and this can't connect to this portion. So this has to go through that way. And we don't know if it goes that way or it goes this way. So this must go that way. That has to be 6 in length. Cannot go, that has to go here, has to go there. This has to connect that way. So 1, 2, 3, 4, 5, 6, 7. This is 9 going that way or this way. This is 1, 2, 3, 4, 5, 6. And that goes that way. We cannot go longer here, so we must connect directly to here, and that must be 5 then. So this has to be 6, because this is already 6 in length. So no 5 there, it's at least 6. And this has to be 5, because we have 6, 7, 8, 9 already in the column. So that's 5, which connects directly to there. Okay, and so this has to be in 6 in length. 1, 2, 3, 4, 5, 6. So this is 6. And the rest we have to figure out from the other clues. Okay. Which means there's no consecutive digits here. Okay. What's the most restrictive? Column 5. We have 1, 2, 3, 4 left. That's it. That's kind of not... That's not too helpful. Remaining digits of row 3, we have 1 through 5 left. This 1 through 5 cannot be 1 or 2 here because of 1 or 2 in the column. So it's consecutive with this one, so it's 3 through 6. This is consecutive with that one, so it's 1 through 6 there. No 2 or 5 remaining in column 4 because of 2 or 5 in the column. Therefore, this can't be 1, and this can't be 6. This is 3, 4 as a pair. And 3, 4 as a pair is consecutive, or eliminates 3, 4 in the rest of the box, so no 3, 4 there. That makes this 1 and 2 as a pair, which eliminates 1 and 2 in the rest of the column. So this is 3, 4 and consecutive. Okay. 5 eliminates 5 here. Where is 5 in row 3? It must be one of these two digits. Okay. 3, 4 as a pair. Rest of column 4 has to be 1, 6, 7, 8. Oops. Don't know how I got that Okay, yeah, I do not. I know. No 1 or 8 here because of the 1-2 pair and the 8 in the box. No 6 here because of 6 in the row. Remaining digits of box 2, we have 6, 7, and 5. And with a guaranteed 5 there. Remaining digits in column 2, let's call it column 6, are 2, 6, 7, and 9. This cannot be 6, that's consecutive with 5. This can't be 7 or 9, that's consecutive with 8. This can't be 6, that's consecutive with, that has 6 already in that row. Remaining digits of column 1. We have 1, 3, 4, 5, and 8. No 5 here because of 5 in the row. These are consecutive with this. Remaining digits of column 2. We have 1, 2, 3, 5, and 8. 5 can't be here because of 5 in the row. This digit cannot be 5, that's consecutive with 6. This can't be 8, it's consecutive with 7. These digits are consecutive, so we cannot have a 1 here, that can't be 2 there. 1 and 2, 2 and 3, 3 and 4, 4 and 5. This can't be 5, that's not consecutive with 4 or 6 there. 8 cannot be either of these spots. 8 it would be consecutive with 7 or 9, which can't be there. 8 has to be consecutive with 7 or 9, which can't be there. So none of those are 8. Hmm. 9 eliminates 9 here. Where is the 9 in box 5? Can't be here, can't be here because 9's in the column, can't be here because 9 in the row, can't be here because that's consecutive with 8, so 9 has to be here. Interesting. Where is 9 in row 4? Cannot be here because 9's in the column, can't be here because 9's in the row, so 9 has to be there. That gives us 9 eliminates 9 here, so this is 7 and 9. That gives us 8 and 9s. We know where the last 9 has to be. It has to be there. Okay, remaining digits in column 8. We have 3 through 7, right? Yep. No 6 here because of 6 in the row. Remaining digits of column 7. We have 1, 2, 4, 7, 8. This can't be 7, that's consecutive with 6. This can't be 5, that's consecutive with 6. Where is the 5 in row 3? It must be here. We have a 3, 4 pair in row 3. That eliminates 3, 4 in the rest of the row. 3 and 4 consecutive only with 3, 4, or 5 here, which means one of these is a 4. It's either 3 or 4 or 4 or 5 to be consecutive. That eliminates 3 and 4 in the rest of the column. 5 is here. Remaining digits in column 9 are 1, 2, 3, and 8. Okay. 5 eliminates 5 in the rest of the box. Okay. Five eliminates 5 in the rest of this row. 5 is one of these two. 2 is consecutive with 3, so this can't be 3. 9 is consecutive with 8, so this can't be 8. Where is the 7 in box 3. Can't be here, that's consecutive with the 6. Can't be here because of 7 in the column, so 7 has to be one of those two, which eliminates 7 in the rest of the row. So no 7 here, it's 6. No 6 or 7 there, it's 5. No 5 or 6 there, it's 7. Interesting. Okay, 7's consecutive with 8, so this can't be 8. 7 eliminates 7 here, so that's 2, which eliminates 2 there, so it's 6. 6 eliminates 6 in the rest of the box, so this is 1, 7, 8 as a triplet. Actually, we should have gotten that. Oh, well, anyways. Yeah. 6 eliminates 6. You already knew that had to be 6. Interesting. Where is 6 in row 5? Cannot be here because 6 in the boxes. Can't be here because 6 in the column, so 6 has to be there. Therefore, this cannot be 5 because that would be consecutive with the 6. We have a 3-4 pair now in column 8, which eliminates 3 and 4 in the rest of the column. No 3 here, no 6 here, it's 7. That means this can't be 7, it's 5. 7 eliminates 7 here. 5 eliminates 5 here. So this is 2 with 1 or 3, or this is 3 and 4. Okay. 8 cannot be here, that's consecutive with 7. So we have to have a 7 and an 8 on this line. If either the 7 or 8 is there, that would be consecutive with the other 7 or 8 in the column. So this cannot be 7 or 8. We have a 1, 2, 4 as a triplet. This can't be... That's a 1, 2, 4 as a triplet in column 7. That eliminates 1, 2, 4 in the rest of the column. This can't be 7. That's consecutive with 6. So this must be 8, which makes that a 7 there. 8 is eliminated in the rest of this box here. 2 eliminates 2 here. So where's 2 in column 7? It must be one of these 2 digits. That eliminates 2 in the rest of the box. 2 eliminates 2 in the rest of this row. 8 eliminates 8 in the rest of this row. So no 8 there. 7 eliminates 7 here. Okay. Remaining digits. Where is 8 in row 1? Cannot be here because of 8 in the column, and the rest can't work because of the consecutive, the Kropke dot there, the way that this worked out there. So it must be 8 here. 8 eliminates 8 here. This is 1 or 3. 7 cannot be consecutive with 8, so the path has to go that way. And we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is path length 9. We have 1, 2, 3, 4, 5, 6, 7. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. So therefore both of these are 9. This is size 2. Size 2. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. We don't have to color that anymore. This is size 2. Size 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So therefore this is 6. That's 5. This is 4. So this is 5. That's 4 here. This is 3 there. So this is 4. This is 2 there. So this can't be 3 as the largest. This is 5 because this is 5 length. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So 6 is the longer one. And this is 9. So that's all the huts. Right, consecutive. So let's fill out the rest of column 3. We have 1, 2, 3, 4, 6, and 7. What is eliminated from here? 6 and 7 for the rest of row 1. No 7 here because of 7 in the box. Where is 6 in box 1? Can't be here because of 6 in the rows. Can't be here because of 6 in the columns. So 6 has to be there. That eliminates 6 in the rest of the column here. Well, we already knew that anyways. This 7 eliminates 7 here. Where's the 7 in column 3? It has to be here. So this is 7, therefore this can't be 7, and it can't be 8. That's consecutive with the 7 there, so this is 1. 1 eliminates 1 here, so it's 7, and eliminates 1 there, so that's 8. 1 eliminates 1 in the rest of the row, so this can't be 1, it's 4. No 1 here, no 1 or 4 here. This is a 3-8 pair that eliminates 3-8 in the rest of the box. 4 eliminates 4 in the rest of the column. 4 eliminates 4 here, so that's 3. 3 eliminates 3 here, so it's 4, which eliminates 4 there, so it's 3, which eliminates 3 there, so it's 4. No more 4 here. 6 cannot be consecutive with 5. Where is the 5 in box 1? Can't be here anymore. Can't be here because of 5 in the row. Can't be here because of 5 in the row, so 5 has to be there. That eliminates 5 in the column here. This is 1, 4 as a pair, which eliminates 1, 4 in the rest of the column. No 1, 4 there. It's 3, which is consecutive with 2. That's 3 in the corner. We celebrate because we're close to solving this. 2 eliminates 2 there, so it's 1. No 1, 2, or 3 there. It's 8. No 1, 2, 3 there. It's 4. 2 eliminates 2 there, so it's 1 and 2. This can't be 1 anymore because of 1 in the box, so it's 3. 3 eliminates 3 there, so it's 8, which makes that 3. This can't be 1 or 2, so this has to be 5. 1, 4 as a pair eliminates 1, 4 in the rest of the box, so no 1, 4 there. It's 2. 1 eliminates 1 here, so it's 3 and 1. 4 cannot be consecutive with 5, so this must be 1, which makes that 4. This can't be 1 or 3, so that's 2, which makes this 1. And 3 eliminates 1 eliminates 1 here, so it's 2 and 1. 3 eliminates 3 here, so that's 4 and 3. And that's the solution. I think I would classify this as hard. Maybe it's just me. Maybe I'm just not very good with loops that can touch itself orthogonally. But it feels a lot harder than just challenging to me. And I think that would be the case with most people. Though, I mean, I have been wrong before, particularly because, like, for example, a lot of people rate anti-knights much easier than I would consider it. Because I'm bad at anti-knight puzzles. Yeah, but this doesn't feel like it's just a challenging one, right? This was a lot of hidden logic trying to figure out, okay, well, if I put the loop going a certain direction this way, what does that entail for the rest of this? So I feel like this is more hard level than challenging. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.